All right, guys, today we got the rational root theorem, and one more theorem also. You might want to just sit back on this one, take some good notes. It might be a little bit longer than usual, but that's because the problem's a little bit longer than usual. So let's hit it. First of all, the rational root theorem is this. Basically, it says every possible rational solution of a function comes from this list. It comes from every factor of the constant term, which is the last number, and every factor of the leading coefficient. So let me show you one real quick. So let's say I had this right here. Let's say I had 2x squared minus 5x plus, 7. Any possible rational, now this is for rational numbers, which are not square roots, not decimals that go forever. Rational numbers are numbers that stop or repeat, or fractions. You put all the factors of 7, which are 1 and 7, over all the factors of 2, which are 1 and 2, and they're positive and negative factors. That's why I put the plus or minus in the front. So I'm going to put 1 and 7 over 1, and I'm also going to put 1 and 7 over 2. And what that list is right there, out of that list, that's actually 8 numbers because of the plus or minus. Rational answers or rational solutions for this function, or zeros, come from that list. Okay, so there's 8 to choose from. Let me show you a better example and work the whole problem. It says find all the rational solutions of x cubed minus 8x squared plus 11x plus 20. And so what I'm going to do first is I'm going to make my list. So I'm doing the factors of the last number, which is 20. The factors are 1, 2, 4, 5, 10, and 20. And the good news is the first number is just 1. So I'm putting all these numbers over 1. I'm not going to write the 1 on the bottom, but 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, 20. And if you need to put the 1 down there, obviously you can, but those are just the ones. Then what we're going to do is we're going to take our calculator, punch in the function, graph it, and see where it crosses the x-axis. Because we're looking for zeros or solutions, it should cross at one of those spots right there. All right, and I'm looking at the graph right now. It looks like it crosses at -1. So I'm going to put -1 in my box. You have to prove that it does. To be honest, you can't tell by looking at your calculator, because if it was 1.1, it would look exactly like the same thing. So, or -1.1. So let's do our synthetic here. Bring the 1 down, multiply, add, look at this. Now, the reason I know it works is because I got 0. That is a real 0. And because I now have it down to these 3 terms, I started with x cubed, which means that now I'm down to x squared minus 9x plus 20. And that factors. Like I can go x minus 5, x minus 4. So the 3 real solutions are, remember, 2 of them come from there, positive 5 and positive 4. And don't forget the one we found first, which is the -1. Okay, and that's what your work's going to look like most of the day tomorrow. Let's do one more. All right, find all real zeros of this one. It's a little bit tougher because my numbers are tougher. So 12 is 1, 2, 3, 4, 6. That's a lot of factors. Factors of 10 are 1, 2, 5, 10. So, oh my goodness, this list is going to be insane. So here we go. I'm putting all of them over 1, plus or minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 2 over 1. That's these numbers. Those numbers go on the top. Then I'm putting over 2, 1 over 2. Now the good news is I don't have to put 2 over 2 because I've already got 1. 3 over 2. 4 over 2 I don't have to put because I've already got 2. 6 over 2 is already there. 12 over 2 is already there. So that wasn't as bad as I thought. Put them over 5, 1 over 5, 2 over 5, 3 over 5, 4 over 5. This is quite a list. 6 over 5, 12 over 5. And again, all I'm doing is I'm putting the factors of the last number over the factors of the last number. I've got to do one more thing. 1 over 10, putting over 10 now. 1 over 10. I don't need to put 2 over 10 because I've got 1/5. 3 over 10 I need. 4 over 10, I've already got 2/5. 6 over 10, no. 12 over 10. Okay, so that's the whole list. Thank goodness. That's quite a list. Okay, now, same deal. I'm punching in my calculator. Going to see where it looks like it crosses. Okay, where it's reasonable. And, if we get a fraction, we get a fraction. That's okay. And it looks like it's crossing between 0 and -1. Which means maybe -1/2. So I'm going to try the -1/2 in the box. 10. And remember, the way I'm going to be able to tell if this works is if I get 0 at the end for my remainder. So I'm bringing the 10 down. -1/2 that's -5. Add those up. Half of 16 is 8. It's positive. That's -34. Half of 34 is 17. This looks great. -1/2 times 24 is -12. Look at that. Now, because I still have 4 numbers down there, and it doesn't, the coefficients don't look like it's going to factor by grouping whatsoever. I'm going to look back at my calculator and see if I can find another one. Let me see here. Yeah, it looks like it's crossing somewhere between 0 and 1, but closer to 1. So it looks like 3/5 is this. So let's try 3/5 right here. See what happens. Now we're going to try 3/5 with these bottom numbers though. 10, -16, -34, and 24. Don't do the original numbers. Let's do those instead. So I'm going to bring down the 10. If I do 3/5 times 10, I get 6. Add those up. Again, 3/5 times 10. This time I get -6, which is -40. If I do 3/5 of -40, wouldn't you know it, get -24. So that leaves me 10x squared. When I get down to 3 numbers, that's what I want, because I can solve any quadratic, and you can too. First of all, I have to see 10s everywhere, so I'm going to take the 10s out, like that. Now, there's no factors of 4 that will give me a -1, which means, guess what? X equals -b plus or minus the square root b squared minus 4ac all over 2a. So here's what I get. I get 1 plus or minus square root of 17, which I love because you can't break that down at all. 2. Now, that counts as 2 solutions because of the plus or minus sign. So we'll take that. The last answer we found was 3/5, and another 0 we found was -1/2. So there's my 4. And that's it. Okay, that's a lot. Hang in there. Again, I don't expect you to get every bit of this just from watching this, but like, again, as usual, by the time we leave class tomorrow, I want you to feel pretty darn good about it. All right, one more thing that you need to know, and that is this. If a plus b is a 0, like if you get like we just did quadratic, okay, and we got an answer with a square root in it. If you get a plus b as an answer, the conjugate is also a 0 or also a solution every time. If you go back to the last slide, I think we had something like 1 plus or minus square root of 17 over 2, something like that. Notice the top, 1 plus square root of 17, 1 minus the square root of 17. They are conjugates. They always come in conjugate pairs. So what we're going to do is we're going to use that to go backwards here and write the function. Okay, so here we go. Last slide, hang in there. Write a polynomial function f of least degree that has rational coefficients, means no decimals in the coefficients, a leading coefficient of 1, and the zeros are 3 and 2 plus or minus 5. Okay, here's the first thing you need to know. If 2 plus 5 is a 0, that means 2 minus 5 is a 0. It's about to get crazy here. Watch this. So I'm going to say f of x equals, and I'm going to write them as factors. Where did the 3 come from? The 3 came from here. Where did the 2 plus square root of 5 come from? It came from here. Where did the 2 minus the square root of 5 came from? It came from here. Okay, now here's the bad news. Your job is to multiply every bit of this out. And it's going to be a doozy. So I'm going to save that x minus 3 for the very last thing. Notice I put little parentheses in these big parentheses and have a minus sign in the front. Okay, so I'm going to rewrite that. I'm going to distribute the parentheses like that. Distribute the minus sign, I should be saying. Distribute the minus sign through the parentheses is what I meant. All right, now, here's something I need you to notice. Still don't worry about the x minus 3. That's going to be the last thing we do. Look at the big parentheses. They both have an x minus 2. And then they have a positive square root of 5 and a negative square root of 5. What that means is they're conjugates. And don't forget how we do conjugates. We do fl. So I'm about to do conjugates on the inside parentheses. So I'm going to do first. Now, what I just underlined, the x minus 2, those are first. If I do x minus 2 times x minus 2, I get x minus 2 squared. If I do negative square root of 5 times positive square root of 5, I get square root of 25, which is just 5. Anytime you do 2 square roots are exactly the same. When you multiply them together, you can just pull the number out. Okay, so still don't worry about the x minus 3. Inside that parentheses, I'm going to go square, multiply, double, square, and I've got the minus 5 still. Now, one more step with the x minus 3. I can combine that positive 4 and negative 5 into a negative 1. All right, and there's a reason a few days ago we learned how to multiply stuff like this. Okay, so what I'm going to do is I'm going to take the x all the way through there, and I get x cubed minus 4x squared minus 1 times x. Now I'm going to take the negative 3 through, negative 3x squared plus 12x plus 3. Last step, combine anything you can. I got x cubed. I have those two x squares, which are negative 7x squared. Combine your x's, which is plus 11x, and I got that plus 3 at the end. And there you have it. Guys, that's a doozy. Golly, we'll do a couple of those though. You can do it. It's a lot of math, a lot of algebra to get through, but the steps aren't that bad. Just a lot of math, which is awesome. All right, we'll work on tomorrow like we always do, and I will see you then.